Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signals and Systems Analysis. In this video, we will discuss on the solution to sample problem on how to determine zero input response of a linear differential system. So in this question, you are given this linear differential equation, okay, with these two initial conditions, and you are asked to determine the zero input response of the system. Okay, so let's do this one by one. So the first step is to assume y of t equals to c e lambda t. Okay, so which means you will have, because for the second order differential equals to c lambda e lambda t squared. For the first order differential, you will have, which is the dyt over dt, you will have c lambda e to the power of lambda t. Okay, so the next step, step 2, is you substitute. Okay, so you want to substitute the original equation here with the lambda operator that we already assumed in step 1. Okay, so you will have now c lambda square e to the power of lambda t plus 3 c lambda e to the power of lambda 3 plus 2 c e lambda t equals to, because we are solving zero input response, and we know that for zero input response, it means the external output equals to 0. So x of t equals to 0. So here you will have equals to 0. Now step 3, you want to factorize c and the exponential. So you have c and e lambda t outside. So in the bracket, or here, you will have lambda square plus 3 lambda plus 2 equals to 0. Okay? Now, if you remember in the slide, we say that this part over here is q lambda, which is the characteristic polynomial. So the next step is you wanted to determine the root of the characteristic polynomial. Okay, so step 4, you wanted to determine root. So you will have lambda square plus 3 lambda plus 2 equals to 0. Okay, so here you will have lambda equals to minus 1n lambda equals to minus 2. So this is known as the characteristic polynomial, characteristic roots. Okay. So the next step, let's say step 5, is you replace the roots back into the equation. Okay. Okay, let's do this. Okay. So you will have y(o) of t equals to c1 e lambda 1t plus c2 e lambda 2t. Okay, so this equation is given, okay, in the slide. So if you watch the video where I discuss zero input response, okay, you will know where this equation come from. So if you replace the root, you will have y(o) of t equals to c1e minus t plus c2e minus 2t. Right. So the next step is to determine c1 and c2. So for y0, okay, which is equivalent to 0, we will have c1 e to the power of 0, okay, t equals to 0, plus c2e to the power of minus 2 times 0. So in this case, you will have 0 equals to e to the power of 0 is 1. So you will have c1 plus c2. For the y dot, which is equivalent to minus 5, you will have first you will have to differentiate y(o). Okay, so y of t equals to minus c1e minus t minus 2c2e minus 2t. Okay, if you differentiate this, okay, so minus 5 equals to minus c1e minus 0 minus 2c2e minus 2 times 0. So you will have here minus 5 equals to minus c1 minus 2c2. Right? So now you have these two equations. two equations and two unknowns, C1 and C2. So I think you have learned in your mathematics course how to solve this. And so you will get at the end C1 equals 2 minus C2. So C1 is minus 5 and C2 is 5. Okay, if you solve these two equations, the equation number 1 and equation number 2, right? So your zero order response is equivalent to y o of t. In this case, you have minus 5 e minus t plus 5e minus 2t. Okay. So this is your zero input response, or the zero, we can also say this is the zero input component of y of t. Okay, right, so I will see you in the next video where I will discuss different types of roots, okay, that you can get when you solve, okay, or when you find the roots of the characteristic equation. Okay, so I end this video here. Thank you.